In the summer of 2003, a rocket stood tall on the launch pad at Cape Canaveral, Florida. Inside its payload fairing was a robotic explorer destined for another world. Its name was not yet known to the public, but it would soon become a symbol of perseverance and courage. This rover, eventually called Spirit, was part of NASA's ambitious Mars exploration rover mission. Its job was to search for signs of water and clues about whether life may have once existed on the red planet. Spirit was not expected to last long, just 90 Martian sols, or about 92 Earth days. It was not built to survive harsh Martian winters or endure violent dust storms, and it was never designed to climb Martian hills. But Spirit would do all of this, and more. Before launch, Spirit was known simply as MER-A, the first of two twin rovers constructed for this mission. The other, which would later be called Opportunity, followed weeks behind. The name Spirit came from a 9-year-old girl named Sophie Collis, a Russian-American student who won a national essay contest. Her words, "It was dark and cold and lonely. At night, I looked up at the sparkly sky and felt better. I dreamed I could fly there," resonated with millions. The name embodied more than technology. It carried human hope. Spirit was roughly the size of a golf cart and weighed about 400 pounds, yet it held inside it the dreams of scientists, engineers, and children around the world. As it sat atop the Delta II rocket, countdown ticking, humanity waited, ready to send this mechanical geologist across millions of kilometers toward the dusty unknown. On June 10, 2003, the Delta II rocket carrying the Spirit rover thundered into the sky above Cape Canaveral. It was the beginning of a voyage across the solar system. After reaching a parking orbit around Earth, the spacecraft waited patiently. Then, with precise timing, a final push from the upper stage sent it into a heliocentric orbit, one that would intercept the path of Mars. What followed was a journey of nearly 7 months. During this time, Spirit conducted 4 course correction maneuvers to stay on track. It approached the red planet at an astonishing speed of 19,000 kilometers per hour. But the most dangerous part was not the trip through space. It was the descent to the Martian surface. Landing on Mars is an engineering nightmare. The planet has just enough atmosphere to cause problems, but not enough to slow a spacecraft on its own. This makes the entry, descent, and landing phase, known by NASA as EDL, a terrifying 6-minute ballet of physics and precision. There is no time for real-time adjustments. By the time a signal reaches Earth, the landing is already over. Spirit had to do it all on its own. 15 minutes before atmospheric entry, the cruise stage separated, leaving Spirit protected inside a heat shield and aeroshell. As it plunged into the thin Martian air, the outer shell heated to over 1,600 degrees Celsius, while the inside remained near room temperature. Spirit was now falling fast, and the clock was ticking. At an altitude of around 6 kilometers, Spirit deployed a supersonic parachute to slow its descent. Just half a minute later, the bottom of the heat shield detached and fell away, exposing the lander. Spirit, still tethered inside, began to unwind on a bridle beneath the parachute. 10 seconds later, the radar activated, scanning the Martian terrain to determine altitude. With only a few seconds remaining, retro rockets mounted on a descent stage fired, rapidly slowing the lander. But that was not the final step. At just under 9 meters above the surface, airbags inflated around the lander. The tether was cut, and Spirit fell, encased in its protective shell. It hit the surface at a speed of about 14 meters per second and began to bounce. For more than a dozen seconds, Spirit bounced across the Martian plains, striking the ground almost 30 times. Each impact could have meant the end, but the airbags held. Finally, the lander rolled to a gentle stop nearly 250 meters from the point of first impact. The 6 minutes of terror were over. Spirit had made it. The date was January 4th, 2004. Spirit had touched down inside the Gusev Crater, a 200-kilometer-wide basin believed to be the site of an ancient lake. It was an ideal location for finding evidence of water in Mars's past. Now, still wrapped in airbags, Spirit sat silently on a red desert unlike anything ever seen. And then, one by one, its systems began to awaken. After verifying its health, Spirit deployed its solar panels and slowly rolled out onto the dusty terrain of its new home. The rover began transmitting its first data using orbiters already circling the planet, Mars Odyssey and Mars Global Surveyor. These first transmissions included spectacular panoramic images of the landing site. Using a combination of black and white images taken through multiple filters, NASA engineers created the first high-resolution, true-color views from Spirit's position. One image measured 4,000 pixels wide and 3,000 tall. At the time, the most detailed color image ever taken on another planet. The landscape was raw and alien, with scattered rocks, gentle slopes, and a horizon that stretched under a salmon-colored sky. Spirit's mission had officially begun. In every direction were geological features that promised insight into Mars's history. Nearby hills, later named Anderson, Brown, Charla, Clark, Husband, McCool, and Ramon, offered natural targets for future exploration. A shallow depression, just meters away from the landing site, was named Sleepy Hollow. This area quickly became the first objective, as it might expose subsurface materials and offer a glimpse into the geological layers below. The entire landing site was named the Columbia Memorial Station, in honor of the 7 astronauts who lost their lives in the Space Shuttle Columbia disaster 1 year earlier. Spirit wasted no time and began its investigation by approaching Sleepy Hollow. It was an auspicious start, but just days later, the mission was nearly lost. On Sol 17, 17 Martian days after landing, NASA's Deep Space Network suddenly lost all contact with Spirit. Engineers were left in silence, unsure of what had gone wrong. Then, a single beep came through. Spirit was alive, but in distress. It had entered fault mode, rejecting commands and operating only sporadically. The cause? A software flaw caused the rover to endlessly reboot and overheat, threatening its very survival. If left unresolved, The Spirit mission would end just as it had begun. But the engineers on Earth, thousands of kilometers away, responded with ingenuity. They commanded the rover to bypass its corrupted memory and perform a full reformat. And incredibly, it worked. Spirit was saved. The rover had set foot on Mars, endured a harrowing landing, and survived its first brush with death. Its real adventure was only just beginning. Martian days after its successful landing, Spirit encountered a crisis that nearly ended its mission. Without warning, NASA's Deep Space Network lost all contact with the rover. For a day, there was silence. Then, on the following sol, a faint signal emerged, just a single beep. That beep told engineers everything they needed to know. Spirit was alive, but something had gone terribly wrong. It had entered a fault protection mode, limiting its operations and refusing most commands. No one knew the exact cause. Could it be a hardware failure? If so, the mission would be over. But if it was a software issue, there might still be hope. The clock was ticking, and the cold Martian nights were unforgiving. Through that narrow window of communication, NASA's team instructed Spirit to transmit basic engineering data. What they discovered was alarming. Spirit was stuck in an endless cycle of reboots, each time trying and failing to resume normal function. The problem originated in the rover's flash memory, which had become overwhelmed with too many files. Most of these were unneeded leftovers from the journey through space. Worse still, a command meant to shut Spirit down and prevent further damage, called "Shut Down Dammit Until," was ignored by the rover. It had burned through its battery reserves and risked overheating its electronics. Every failed reboot shortened Spirit's life. The engineers had to find a way to break the cycle, or watch the mission die before it had truly begun. Fortunately, the rover's design included a contingency. Spirit could be forced to boot up without using its flash memory. This would bypass the corrupted software loop and allow access to critical systems. The engineers issued the command, and against the odds, it worked. Spirit stabilized and finally responded properly. But the danger was not over. The team now had to carefully clean the file system, deleting hundreds of useless data packets. They also reformatted the entire flash memory to ensure no corruption remained. For a spacecraft millions of kilometers away, this was a risky and delicate operation. Any error could render Spirit permanently unresponsive. Yet the team pushed forward, bold, cautious, and absolutely determined. On Sol 32, Spirit emerged from the shadows of malfunction. The rover was fully operational once again. This moment marked a quiet triumph, not just of engineering, but of human resilience. Spirit had crossed the void of space, survived a violent landing, and now endured its first major failure. And it had come back stronger. The experience revealed not only the importance of redundant systems, but also the incredible ingenuity of the team behind the mission. They had saved Spirit using tools crafted years before launch, preparing for problems they hoped would never occur. This recovery was not just about fixing a robot. It was a rehearsal for the future of interplanetary exploration. Mars had thrown down a challenge, and Earth had answered. With its systems restored and its memory clean, Spirit was ready to resume its journey across the Red Planet. The near-death experience had changed the mission's tone. What began as a carefully scripted exploration now became a story of survival and adaptation. From this moment forward, every soul Spirit operated was a gift. Engineers no longer assumed the rover would survive from one week to the next. Instead, they cherished every byte of data it returned, every rock it studied, and every image it captured. Mars had tested Spirit, and Spirit had endured. The recovery was complete, but greater trials and even greater discoveries still lay ahead. With its systems fully restored, Spirit turned its attention back to its scientific objective: the search for evidence of water on Mars. Geology would be its guide, and rocks would serve as time capsules, holding clues about the planet's volcanic history, climate, and potential habitability. Not far from the landing site, the team identified two possible targets for Spirit's first close examination. One was a dusty rock called Sashimi. The other, slightly farther away, was a football-sized stone named Adirondack. Though Sashimi was closer, its surface was coated with loose material and deeply pitted, making it an unfit candidate for Spirit's delicate instruments. Adirondack, by contrast, had a smooth, clean surface, ideal for analysis. Reaching Adirondack required precision. Spirit navigated carefully through the rocky plains of the Gusev Crater, rotating in short arcs and advancing slowly across the terrain. After a careful approach, the rover positioned itself for its first true geological experiment. On Sol 33, Spirit began observations of Adirondack using its suite of instruments: the panoramic cameras, the Muse-Bauer spectrometer, and the microscopic imager. Initial readings suggested that the rock contained volcanic minerals like magnetite, olivine, and pyroxene. These minerals hinted that Adirondack might be similar to basaltic rocks found on Earth, formed by the cooling of molten lava. But to confirm this, Spirit would have to do something no machine had ever done before on another planet: grind beneath the rock's surface. Mounted on Spirit's robotic arm was the rock abrasion tool, affectionately known as the Rat. This tool, no larger than a flashlight, used a diamond-coated wheel spinning at 3,000 revolutions per minute to grind through the outer layers of Martian rock. On Sol 34, Spirit pressed the Rat against Adirondack, creating a circular borehole 5 millimeters deep and 4.5 centimeters wide. This revealed a fresh surface, untouched for billions of years. The rover then brought its spectrometers and microscopic imager close, capturing unprecedented details. The rock was indeed volcanic basalt, providing confirmation that lava once flowed across this now barren region. For the first time in history, humanity had performed a geological experiment on another world. But Adirondack was only the beginning. On Sol 60, Spirit set its sights on another rock called Humphrey. Dark and roughly 60 centimeters tall, Humphrey appeared to have lighter-colored veins running through its interior. After brushing the surface with the rat, Spirit revealed textures that strongly suggested the presence of mineral deposits formed by water. These bright materials within fractures might have been left behind by fluids percolating through the rock, either from ancient groundwater or surface runoff long ago. The discovery added weight to a theory that Gusev Crater may once have held a lake, fed by the ancient outflow channel known as Ma'adim Vallis. Spirit was beginning to piece together the puzzle of Martian water. Each rock Spirit analyzed told a different chapter of Mars's ancient story. Some, like Adirondack, were volcanic and relatively unaltered, shaped by fire. Others, like Humphrey, bore signs of erosion and chemical alteration, likely by water. This contrast helped scientists map the evolution of the Martian environment. More importantly, the data provided evidence that water once existed, not only as ice or vapor, but in liquid form, flowing through cracks, dissolving minerals, and leaving behind telltale chemical traces. Water is essential for life as we know it, and Spirit's discoveries suggested that the red planet may once have harbored the necessary conditions for microbial organisms to emerge. Spirit continued its geological journey toward a prominent feature known as Bonneville Crater. On Sol 65, the rover arrived at the edge of the crater, a shallow bowl roughly 200 meters in diameter. Spirit's discarded heat shield was visible nearby, offering a rare chance to inspect the protective structure that had survived entry through the Martian atmosphere. However, after examining the terrain, the science team decided against sending Spirit down into the crater. The rocks along its rim were not geologically compelling, and the descent posed a significant risk. Instead, the rover turned its attention toward the Columbia Hills in the distance, an inviting collection of elevated terrain that could hold even deeper secrets. By Sol 118, Spirit had already exceeded its original mission timeline. It approached another crater, smaller than Bonneville, known as La Hontan. Measuring just over 50 meters across, this crater contained soft, sandy terrain that posed a threat to Spirit's mobility. To avoid becoming trapped, the team directed the rover to navigate around it. The journey across the plains of Gusev was challenging, but rewarding. Each obstacle taught the engineers more about how to guide their robotic explorer, and each new rock expanded our understanding of Martian history. Spirit was proving itself not just as a survivor, but as a true pioneer, one capable of unraveling the ancient secrets buried beneath the red dust. After months of exploring the flat plains of the Gusev Crater, Spirit turned its gaze toward a distant cluster of hills it had glimpsed from its landing site. These were the Columbia Hills, rising like ancient monuments from the red dust. They offered a promise of geological diversity, of stories waiting to be told in stone. Spirit began its slow journey, traversing the cracked, dusty terrain, one cautious meter at a time. Along the way, it passed the rim of La Hontan Crater, a shallow pit surrounded by fine sand. That sand could easily trap the rover's wheels, so Spirit veered off course to avoid the danger. Navigation was careful and deliberate. Each obstacle dodged, each ridge crossed, was a small triumph on a larger quest for knowledge, As Spirit approached the base of the hills, something went wrong. The right front wheel began drawing up to 3 times more electrical current than the others, a silent red flag. The motor was struggling. Engineers on Earth considered possible causes. Maybe debris had jammed the mechanism, or perhaps congealed lubricant had hardened in the cold Martian air. Spirit had heaters built into the wheel to prevent this very problem, but no one could be sure they were working. NASA responded with diagnostic tests, imaging, and recalibration. Spirit still moved, but its progress was slower and less certain. The risk of permanent wheel failure loomed large. To preserve the mission, the team would have to get creative. And so, on a lonely plain of another world, the rover began to reverse. Spirit's engineers decided to do something unconventional: drive the rover backwards. This maneuver reduced the strain on the failing wheel, allowing the other 5 to bear the load more efficiently. The idea was simple, yet bold. Instead of pushing the damaged wheel into the Martian soil, Spirit would drag it behind, limiting resistance and preserving energy. The solution worked. Spirit resumed its journey with newfound confidence, even if the path forward now meant looking over its shoulder. This small act of ingenuity was a powerful reminder. Space exploration is not just about advanced technology, but about human adaptability in the face of the unknown. Spirit, battered but unbroken, climbed onward toward the foot of the Columbia Hills. To prepare for the steep ascent ahead, Spirit underwent what the team affectionately called a 3,000-meter tune-up. This involved a series of calibrations and repairs. Engineers adjusted the hazard avoidance cameras, corrected positional targeting errors, and conducted visual odometry tests to refine Spirit's ability to measure its own movement. The most daring step was the activation of a deep sleep mode, designed to conserve energy by powering down non-essential systems overnight. But this came with a risk. With the heaters turned off, Spirit's thermal emission spectrometer might never wake up again. Just in case, the rover performed a final set of observations before slipping into Martian slumber. In this delicate balance of science and survival, Spirit was learning how to heal itself. At the base of Husband Hill, Spirit faced one of its greatest physical challenges yet. This peak, towering over 100 meters above the surrounding plains, would be the tallest elevation the rover had ever attempted to climb. The slope was steep and the terrain unpredictable, filled with soft soil and scattered rocks. To complicate matters, a thick layer of dust had begun to settle on Spirit's solar panels, slowly choking off its energy supply. With sunlight fading, the rover's days of exploration seemed numbered. But then, in a remarkable twist of Martian fate, a dust devil swept across Spirit's path, lifting the debris from its panels and restoring its power to nearly full capacity. The climb was back on. As Spirit ascended the slopes of Husband Hill, it made frequent stops to investigate unusual soil and rock features. One of the most important discoveries came not from a planned experiment, but from a fortunate accident. While dragging its malfunctioning front wheel through the soil, Spirit unearthed an area rich in salts and phosphorus, known as Paso Robles. This region, bright and chemically distinct, hinted at the past presence of water. Such deposits could have formed in wet, acidic environments, the kind where microbial life might have once thrived. Spirit's very injury had become an unexpected advantage, turning its path into a trench that revealed what lay just beneath the surface. Every setback, it seemed, carried the seed of discovery. After months of slow and careful climbing, Spirit reached the summit of Husband Hill. From this lofty perch, it captured one of the most iconic images of the mission: a full 360-degree panorama composed of more than 600 individual frames. For the first time, Spirit turned its cameras inward and imaged its own body, revealing clean solar arrays glinting under the alien sky. Beyond lay the vast plains of the Gusev Crater, stretching endlessly to the horizon. Off in the distance stood McCool Hill, a potential winter haven the rover hoped to reach. But for now, Spirit stood triumphant. A golf cart-sized machine had conquered a Martian mountain, one careful wheel turn at a time. Even as it scaled Martian hills, Spirit was evolving. Back on Earth, NASA engineers sent software updates to the rover, enhancing its abilities and independence. Spirit learned to make decisions on its own, to choose which images to prioritize, when to extend its robotic arm, and how to navigate without constant guidance. With every upgrade, the little rover became a little smarter. This autonomy allowed Spirit to cover more ground, conserve energy, and act more like an intelligent field geologist than a remote-controlled vehicle. That a machine, millions of kilometers away, could receive new skills. Mid-mission was a triumph of human ingenuity. Spirit was no longer just surviving, it was thriving. From the summit of Husband Hill, Spirit looked out upon new challenges and new mysteries. McCool Hill, its planned winter destination, beckoned in the distance. But with one wheel dragging and the Martian winter approaching, reaching it would be far from easy. The team back on Earth would have to make difficult decisions. Yet, in this moment, Spirit had proven something profound. Despite design limits, mechanical failures, and an unforgiving world, it had climbed higher and seen farther than anyone had dared imagine. From the dust of Gusev to the heights of Husband Hill, Spirit had not just explored Mars, it had redefined what was possible for a machine alone in the cosmos. As Spirit made its descent from Husband Hill, the science team faced a choice. Two promising rocks, Comanche and Miami, stood nearby. Comanche was chosen for its layered texture and striking mineral patterns. When Spirit placed its instruments against the rock's surface, the results were astonishing. Comanche was found to contain nearly 1/4 magnesium iron carbonate, a concentration more than 10 times higher than anything previously observed on Mars. This was not just a mineral. It was a messenger from the past, whispering of ancient Martian waters. The presence of carbonates suggested that this region once held neutral or slightly alkaline liquid water, a far more hospitable environment than the acidic soils found elsewhere. Carbonates are fragile witnesses. On Earth, They dissolve easily in acidic conditions, which means their very survival on Mars pointed to a time when the planet may have been more benign. A time when lakes or springs flowed gently, not violently. The discovery at Comanche implied that early Mars was not just wet, but chemically stable, providing a potential cradle for microbial life. Spirit had stumbled upon one of the strongest chemical indicators of habitability found on the red planet to that point. And remarkably, it had done so with a damaged wheel, aging instruments, and solar panels coated in dust. Even in decline, Spirit was rising to meet its greatest scientific challenges. From the slopes of Husband Hill, Spirit turned toward a curious geological structure known as Home Plate. Seen from orbit, it resembled a flat, layered disk, possibly the remnant of an ancient volcanic or hydrothermal system. As Spirit drew closer, the terrain shifted. Rocks became more finely layered, their edges rounded and split, as if once shaped by flowing water. The surface here was different from the basaltic plains below, richer in variety, more expressive in form. Home Plate was a time-worn canvas painted by ancient Martian processes. The team believed it might hold the clearest evidence yet of past hydrothermal activity, perhaps even explosive interactions between lava and groundwater. It was near Home Plate that Spirit made one of its most important discoveries, and it happened entirely by accident. As the rover dragged its broken front wheel across the soft Martian soil, it churned up something bright and unexpected. Beneath the red dust lay a streak of almost pure white silica. On Earth, such deposits are formed in very specific environments: hot springs, or acidic steam vents known as fumaroles. Both are rich in energy, heat, and chemistry, ideal incubators for microbial life. The discovery was stunning. Spirit, hampered by damage, had inadvertently uncovered one of the most promising signs yet that Mars once had the ingredients to support living organisms. The white silica deposit, brilliant against the Martian soil, was not evidence of life itself, but it was the next best thing. It told scientists that water had not only been present, but had been dynamic. It moved, it reacted, it transformed the very chemistry of the surface. And wherever water moves with energy and time, life, at least on Earth, often follows. Spirit had unearthed more than silica. It had opened a window into the ancient Martian past, a past shaped by warmth, activity, and the tantalizing possibility of biology. That this revelation came not from planning, but from mechanical failure, was a poetic reminder that even broken explorers can find truth in the dust. By late 2007, Spirit was showing signs of fatigue. Dust from the Martian atmosphere had thickened once more, settling on the rover's solar panels like a blanket. Power levels dropped dangerously low, reducing Spirit's ability to heat itself or operate its instruments. Each night grew colder, each decision more critical. Then, as if Mars itself wished to grant a second chance, a sudden gust of wind swept across Spirit's resting place. In a moment, the dust was lifted, cleared almost completely from the solar arrays. Power output soared from below survival levels to more than 600 watt-hours per sol. Spirit, once again, had been granted a miracle. Rejuvenated by the cleaning event, Spirit resumed its mission with a new burst of energy. From the western edge of home plate, it captured one of the most iconic panoramas of the entire mission, a sweeping mosaic of the surrounding terrain, assembled from more than 100 individual frames. In this view, Spirit's own wheel tracks could be seen crossing the red sands, marking the path of its long journey. But there was something else. Near the horizon stood a peculiar rock formation, casting a strange humanoid silhouette. The image quickly spread across the world, with many calling it the Little Bigfoot. Though clearly a trick of perspective and erosion, it reminded the public of just how alien and strangely familiar this world could be. The Little Bigfoot image, while playful in public imagination, underscored something deeper. Mars was not empty. It was filled with shapes, textures, and stories frozen in stone. Every outcrop and ridge held a fragment of its ancient narrative. Spirit had wandered through a place that was once alive, not with animals or trees, but with geological energy. Through dust devils, broken wheels, and years of exposure, the rover continued to reveal Mars's layered history. The landscape, from Comanche to home plate, told of flowing waters, acidic steam, and silent transitions between heat and frost. Spirit had not just taken pictures, it had translated the language of Mars, one rock at a time. Spirit's discoveries fundamentally reshaped our understanding of Mars. The carbonate-rich Comanche rock pointed to neutral liquid water. The white silica exposed near home plate suggested a hot, dynamic past, where hydrothermal activity may have supported microbial life. Stratified formations and chemical compositions hinted at rivers, lakes, and perhaps even underwater eruptions. More than a robotic explorer, Spirit became a storyteller, translating geochemistry into glimpses of Mars's evolution. It confirmed that the red planet was not always cold and dead, but may once have offered warmth, chemistry, and stability, the basic ingredients required for life as we know it. Spirit's mission was a triumph of engineering, yes, but more than that, it was a triumph of endurance and wonder. A machine built to survive for 3 months endured for 6 years, and in that time, it uncovered clues that will guide generations of scientists and explorers. It showed us that the Martian surface is more than barren stone. It is a vast archive of climate, chemistry, and transformation. Even as its systems aged, Spirit pushed forward, drawn by curiosity, driven by purpose. And though it would not last forever, its legacy would. Spirit had become more than a rover. It had become a bridge between 2 worlds and a window into Mars's hidden past. After completing its work at the summit of Husband Hill, Spirit set its sights on McCool Hill, a distant rise chosen for its ideal angle to catch sunlight during the coming Martian winter. But the road there would not be easy. Spirit was no longer the same rover that had touched down 2 years earlier. Its right front wheel had seized completely, forcing it to drag the limb like a frozen joint through sand and stone. Each meter forward became a struggle, every slope a risk. The terrain toward McCool Hill was steep and uneven. With winter approaching and power dwindling, the mission team made a difficult but necessary decision. Spirit would abandon McCool Hill and divert to a safer, closer incline, Low Ridge Haven. Low Ridge Haven was far from perfect. Its tilt toward the winter sun was shallower than McCool Hills, and the risk of energy starvation remained high. But it offered something just as valuable: survival. Spirit settled on a slope angled at roughly 11 degrees, parking itself in a sunward pose. For nearly 8 Earth months, the rover barely moved. It entered a season of stillness, weathering the bitter cold in silence. During this time, Spirit continued to transmit data, capturing the changing sky and monitoring temperature, dust, and radiation. Its mind stayed busy even when its body could not. And on the slopes of that quiet ridge, Spirit made an unexpected visual discovery: 2 dark rocks later suspected to be meteorites from space. The third Martian winter was long and unforgiving, but Spirit endured. While it remained stationary, it continued to contribute valuable science. Among the dark soil and rock fragments near Low Ridge Haven, the rover's cameras captured 2 metallic-looking objects. These were later named Zhongshan and Allen Hills, tributes to both an Antarctic base and a location on Earth where Martian meteorites had been found. The implication was poetic: Martian rocks found on Earth, and now Earth's robot discovering possible meteorites on Mars. Even in stillness, Spirit remained a storyteller, linking planets through silent evidence. It was a reminder that exploration is not always about distance. It is about attention and patience. When spring returned and power levels rose, Spirit began to move again. But its broken wheel continued to drag behind, carving a trench through the soil with every motion. Then, something extraordinary happened. In one of these trenches, engineers noticed a bright streak unlike anything seen before. Beneath the rust-red dust was a deposit of nearly pure silica, white, powdery, and gleaming. On Earth, such silica is formed in very specific conditions: hot springs or acidic steam vents known as fumaroles. Both environments, rich in chemical energy and heat, are known to support microbial life. Spirit had not been looking for silica. It had found it by accident, by injury. Its wound had become a tool of revelation. The white silica was not evidence of life itself, but it was a strong suggestion that life could have once found refuge there. Whether shaped by hot water or acidic steam, the terrain Spirit had uncovered held geochemical fingerprints of habitability. In a world often painted as dead and frozen, this patch of soil whispered of warmth, reaction, and motion. And it was discovered not through advanced planning or complex programming, but through the simple persistence of a damaged machine. Spirit's broken wheel had scraped away more than dust. It had peeled back a layer of Mars's ancient memory. And in doing so, it had rewritten what scientists believed was possible on that distant, silent world. As the third winter faded, something remarkable happened once more. A sudden gust of wind swept over Spirit's resting place, clearing months of dust from its solar panels. Power levels surged back to life. It was the second miraculous cleaning event of the mission, and it arrived just when the rover needed it most. Like an exhausted climber catching a second wind, Spirit lifted its gaze once again and resumed its journey. Reinvigorated, it explored the areas surrounding home plate, taking detailed panoramic images, analyzing rock layers, and continuing to act as Mars's tireless geologist. In its third year on the Red Planet, Spirit was still doing what it was built to do: make history. By late 2009, Spirit approached a site called Troy, near the edge of home plate. The soil here appeared safe, smooth, familiar, but beneath the surface lay a trap. As Spirit attempted to cross, it slipped into a pocket of soft, sandy material, rich in sulfates and volcanic glass. One side sank deeply, while the other remained suspended. The rover was trapped, diagonally tilted, with its undercarriage buried. It was here, before becoming immobile, that Spirit took what would become its final image, a black and white panorama of the Martian horizon. The view was hauntingly beautiful, framed by jagged rocks and long shadows. Spirit had reached its final field site, though no one yet knew it. Engineers back on Earth worked tirelessly for months, running simulations, sending commands, and testing soil interactions at the Jet Propulsion Laboratory. But Troy proved merciless. The Martian soil refused to release its grip. With each passing week, the angle of sunlight worsened, and Spirit's energy dwindled. The team placed the rover into a stationary science mode, hoping it might survive the upcoming fourth winter. But the cold was relentless. Temperatures dropped, and with barely enough power to run its internal heaters, Spirit began to slip into silence. On Sol 2208, the final transmission was received. After that, only stillness. There was no dramatic farewell, no final message. Spirit simply faded into the dust and silence of the Martian night. For months, the team continued to send signals, calling out across the void with hope. But Mars did not answer. Finally, on May 25, 2011, NASA made the official announcement. Spirit's mission was complete. But what a mission it had been. It lasted more than 25 times longer than planned. It traveled over 7,000 meters across rocky plains, climbed hills, weathered dust storms, and uncovered the strongest evidence yet that Mars was once a world shaped by water, and possibly by life. Spirit may no longer speak, but it is not gone. It rests where it fell, still and proud, at peace among the stones it once studied. Its story lives on in every scientist it inspired, every student who looked to the sky and saw something more. Spirit taught us that machines can endure, adapt, and discover, not just as tools, but as extensions of our own curiosity. It proved that exploration is not only about reaching far, it is about reaching deep, into the past, into the unknown, into ourselves. And though its wheels no longer turn, Spirit continues its journey, etched forever into the memory of humanity and into the soul of Mars itself. Spirit was never meant to last this long. Designed for a 90-day mission, it survived for more than 6 Earth years, covering over 7,000 meters across harsh Martian terrain. It weathered winters, sand traps, and mechanical breakdowns. What began as a brief engineering challenge turned into one of the most enduring expeditions in the history of space exploration. Along the way, Spirit sent back over 128,000 images, recorded atmospheric changes, and analyzed rocks that had not seen light in billions of years. It became more than a machine. It became a companion to scientists, a storyteller of alien landscapes, and a symbol of how far perseverance can carry us, even across worlds. Spirit's scientific legacy is profound. It discovered carbonate in Comanche rocks, evidence that Mars once hosted neutral liquid water, capable of supporting life as we know it. Near home plate, it exposed bright white silica, a mineral usually formed in hydrothermal environments like hot springs or fumaroles. These findings shifted the narrative of Mars from a dry, dead world to a place that was once geologically active and potentially habitable. Spirit revealed complex layering in rocks, traces of volcanic ash, and signs of acidic water. It turned hypotheses into data, and data into questions, deeper ones, bolder ones. It laid the groundwork for future missions, shaping where and how we search for signs of ancient life. Spirit taught us that not all failures are the end of the story. When its front wheel jammed, many feared it would spell the rover's demise. Instead, that broken wheel became a blessing. As it dragged through the soil, it revealed what no instrument could have planned for: hidden deposits of pure silica. It was an accidental excavation, a wound that uncovered ancient Martian secrets. Spirit also showed how nature could assist us. Dust storms, once seen as a threat, turned into unexpected gifts, twice clearing its solar panels and extending its life. In every challenge, engineers adapted. They drove the rover backward, rewrote software, and found solutions that redefined mission resilience. Spirit did not just explore, it evolved. What Spirit proved goes far beyond science and engineering. It reminded us that ingenuity thrives under pressure, that persistence can turn broken parts into tools of discovery. It showed the world how a tiny robot, on a planet without voices, could speak volumes. It turned silence into evidence, malfunctions into breakthroughs, and each obstacle into a new chapter. The Spirit rover became a quiet teacher of patience, humility, and the extraordinary beauty of adaptation. It asked us not just to look at the stars, but to follow through, to land, to endure, and to keep going, even when the odds say stop. The name Spirit came not from a scientist, but from a 9-year-old girl named Sophie Collis. Spirit means that I can go anywhere, do anything, she wrote. That simple sentence became the heart of the mission. For millions around the world, Spirit was more than a robot. It was a symbol of resilience, of hope, of the quiet courage to keep moving forward even when everything breaks. In classrooms, museums, and bedtime stories, Spirit inspired a generation to look beyond Earth, to wonder, to ask. It proved that exploration is not just about distance, it is about heart, about the will to see what lies beyond the next ridge. The discoveries made by Spirit continue to ripple through science. Its data laid the foundation for every mission that followed: curiosity, perseverance, and the dream of Mars sample return. Regions it explored, from home plate to Comanche outcrop, are still studied today. Thousands of scientific papers reference its work. Spirit taught us how to read Mars, how to navigate its textures, and translate its chemistry. It showed that even with limited tools and a simple design, a well-guided mission could unlock planetary history. In this way, Spirit became a torch passed from one generation of explorers to the next, lighting the path toward deeper understanding and greater questions. Though Spirit no longer moves, it still rests on Mars, wheels half buried in dust, body angled toward the sun. It remains there, not as wreckage, but as a monument, a silent marker of what humanity can do when curiosity becomes action. It did not need to speak. Its silence speaks volumes. Spirit is not just a story of technology, it is a testament to human will, to try, to fail, to adapt, and to press on. It reminds us that even small things, sent to faraway places, can leave everlasting footprints. In the thin air of a distant world, Spirit endures, not only as a machine, but as a symbol etched into the memory of exploration. If we listen closely, perhaps we can still hear it, not in words, but in echoes. The hum of solar panels, the faint crunch of wheels through Martian soil, the silence after its final whisper. Spirit's journey ended far from Earth, but its impact is deeply rooted in who we are. It asked no reward, sought no glory. It simply gave everything it had to the pursuit of truth. And in that quiet sacrifice, it earned something greater than applause. It earned remembrance. The rover may sleep, but its spirit lives on, guiding our eyes upward, outward, and always forward. In the cold silence of Mars, Spirit came to rest not with a dramatic finale, but with quiet dignity. After more than 2,000 souls of resilience, exploration, and discovery, the rover fell silent, its battery depleted, its wheels stilled, its voice no longer reaching Earth. There were no final words, no goodbyes. But its story had already been written into the dust it stirred, the rocks it studied, and the dreams it inspired. Spirit was more than a machine. It was an extension of human curiosity, a symbol of endurance in an alien world. And like every great journey, it carried with it a beginning, one rooted not in science, but in the imagination of a child. Years earlier, when NASA held a contest to name its twin rovers, it was a young girl named Sophie Collis who gave them life beyond their metal frames. Born in Siberia and once an orphan, she had looked up at the night sky through frost-covered windows, dreaming of distant stars. In her winning essay, she wrote, "It was dark and cold and lonely. At night, I looked up at the sparkly sky and felt better. I dreamed I could fly there." Her words became the spirit behind Spirit. They reminded us that space exploration is not just about engineering or data, it is about hope. Hope that begins in even the smallest corners of the Earth. As Spirit's heaters cooled and the Martian wind gently buried its tracks, its mission came full circle. It began with Sophie's dream and ended by honoring it. Though it now sleeps beneath an alien sky, Spirit lives on in the images it sent, the discoveries it made, and the legacy it left behind. It showed us that even the most fragile machines, when guided by vision and care, can endure beyond expectation, and that sometimes the most distant journeys begin in the quiet longing of a child who once looked up and dared to believe that she could touch the stars. If you enjoyed this video, please give it a like and subscribe to our channel. Let us know your thoughts in the comments. We'd love to hear from you. Thanks for watching, and we'll see you in the next one.